has offered to present and walk us through the RTF product and do a quick demo as well. And he's going to walk us through the best practices and etc. So with that, I would like to invite Mani. Thanks for joining today, Mani. Thanks for offering to speak in this meetup. Please now give a brief intro about yourself, and you can get started with your presentation.
Hello, everyone. Thanks for joining in the lunchtime. So, you may be hungry. So we'll make it informative and more engaging. So my name is Mani Rothroy. I'm a senior technical architect at Extivia. So Extivia, we are a MuleSoft premium partner for the last 8 years, and we're doing integration for the last 20 years as a company. And I'm also doing integration for the last 20 plus years. And many in this group might know me already. We'll focus today on Runtime Fabric. I think that's a continuation of your previous session where one of my colleagues presented about Runtime Fabric on the appliance and the VM bare metal. So we'll take it further and focus on how do we leverage the Runtime Fabric in a containerized environment on public cloud. Shall I start, Ram or Naresh, or you want to talk something?
We have 30 attendees. Maybe we'll couple of minutes and it'll start.
Okay, that's good.
Sure.
In the meantime, if everyone can introduce themselves in the chat, I think that will give us opportunity to network with each other, connect with each other, and that's good for the community as well. Just mention your organization and your location, and if you have any questions about the presentation, you can use the chat to ask questions as well.
Yeah, we can start actually because this is office hours. Maybe just I don't see much. 29 people already there. We can start, Mani.
Okay, sounds good. So I'm sharing my screen. You see my screen, right?
Yeah.
Infinite loop. Okay, good.
Yeah, it's good.
So far, you guys already know what is a runtime fabric, right? The promise of runtime fabric is you get to isolate applications, right? Just like Cloud Hub. You can do the application isolation. You can run multiple versions. You can scale across multiple replicas, and you can also get a highly available application, right? Always on kind of thing. Well, that's all true for a runtime fabric, which is also true for a Cloud Hub. So so far, you might have known already that the biggest difference between a Cloud Hub versus a runtime fabric is Cloud Hub is managed by MuleSoft. Runtime fabric is something you own it. You own it and you completely manage it, right? So that's the biggest difference. Other than that, both of them are the same. So when it comes to runtime fabric, right? So we have two flavors of it. And the one which you guys already discussed in the last meeting was the appliance model, which is typically a bare metal or a VM. MuleSoft will give you a package, which is a bundle, for example, which has a which contains the Dockers and the Kubernetes and all the container services, and you install that on your VM, right? And which you operate and manage. And the flavor of Kubernetes, which is packaged inside of that, is called Gravity VM, right? I'm sorry, the Gravity flavor of the Kubernetes. And the second option, which we are going to talk about today, is the self-managed Kubernetes option. So you pretty much bring your own Kubernetes from the public clouds, and you install Runtime Fabric on it. And there are selected version of Kubernetes from the public clouds. You have three choices right now. Either you can bring a Google Kubernetes engine, you can bring a AKS, which is Azure Kubernetes service, or an Elastic Kubernetes service from Amazon. So three flavors, three options when you talk about bring your own Kubernetes, pretty much. And one thing, the major difference, as I say, right? So you are so Mule is not offering you a packaged Kubernetes engine, right? So you are bringing your own. So that means a Mule org admin, let's say in this example, maybe you guys, right? So your job is, so when you go for a self-managed Kubernetes, right? So it's your responsibility as a Mule admin or a Mule team member is to, when you want to create that, so you create the runtime fabric, you deploy application up there, and you perform other tasks which is inside of that anypoint platform, right? Whereas your cloud admin team, right, who is kind of responsible for standing up that cluster for you in AKS, EKS, or GKE, and kind of assist you, kind of that cluster. I mean, so it's a kind of a liaison between you and you doing the runtime fabric stuff, and the cloud admin doing that cluster, anything to do with the cluster, basically, or the Kubernetes cluster, for example, managing its CPU, nodes, and all that. So the cluster management, Kubernetes cluster management. So that's them, right? So there's a line of separation here. So because when things go wrong, you need to know where is the exact issue, and then like who to reach and how to troubleshoot. And so that becomes much helpful when the time comes. So what are let's look at the use cases, right? So why do I need a self-managed Kubernetes flavor of runtime fabric, right? So there are situations where you are running your whole IT platform, like many of your enterprise applications are already running on AWS, Azure, or GCP. So when I say running, it's not just running on a infrastructure as a service, which is the entry point for any of these public cloud, but rather you are leveraging more of a PaaS solution, or doing some Lambda kind of cool stuff as a function as a service. So you're pretty much at a intermediate to advanced level when you talk about leveraging these public clouds. I'm not talking about enterprise infrastructure as a service, because that's an entry point, as I said. That's not advanced. And your team is well versed with using Docker Kubernetes for your other application, be it Python, Node.js, or Java, or anything else. You're already leveraging that kind of cluster or Kubernetes containerized environment. You're pretty well versed with that. So then, if those two situations applies to you, and Mule, you maybe so you're thinking about Mule, or you already have Mule in a different flavor of things, then I think that calls for an upgrade or adopting a runtime fabric on a self-managed Kubernetes, right? So, and whereas the runtime fabric on bare metal or VMs, right? So which is like well, I want to do some more cloud-like offerings. I would like to do. I'd like to get the benefit of a cloud-like environment. Or the cloud-like feature where you get the application isolations, you get that multiple version of application running, all that cool stuff about cloud. But you want that on-prem, and but you don't have the people, right? You don't have the people who understand the Docker and Kubernetes stuff, right? It's relatively new to your organization. So that makes a call for a runtime fabric on an appliance or a bare metal or VMs, right? And you can always go from one step to another one, because when it talk about MuleSoft, the cool part of that is like your license are portable. So no matter what kind of flavor you go with, you still your total consumption of your course is already part of your subscription. So you can have your some on-prem, some cloud hub, some on RTF. You can do mix and match if you have that enough number of licenses. Okay, moving on. So there are key differentiating factor when we talk about runtime fabric on a self-managed Kubernetes, which we're going to talk today, and runtime fabric on a appliance, or the VM bare metal, right? So I'll pretty much most of them are common. I'll just focus on what is different. And this slide talks about that. So the key feature is which is, as I mentioned already, right? So you are bringing your own cluster environment, which is a Kubernetes cluster, in this case, the AKs, EKs, and GKE clusters, right? Whereas on the VM bare metal, you are it's already given to you part of that installation package. So the RTF package installations, right? That includes that flavor of Kubernetes with that installation. So and one more major thing is like node auto scaling, right? So which is supported. So one thing you should know that you are riding on the MuleSoft. I mean, the whole MuleSoft RTF is riding on a cluster which is already provisioned by all these public clouds, right? So the public cloud cluster offering, or Kubernetes cluster offering, comes with certain things. What does it mean? Like you get that node auto scaling. It's a feature of the Kubernetes cluster from this public clouds, right? It's not a feature of MuleSoft. So so you get that node auto scaling, which you have seen before in runtime fabric, where you can only scale the applications, right, using replicas, but you don't have an option of scaling your nodes, the physical machines, or the VMs, right? You cannot scale. But in this case of the Kubernetes offering of self-managed Kubernetes, you can scale even the nodes. And one thing also, because you are riding on a Kubernetes cluster offered by these public clouds, that security is already there. When I like the edge security, basically the endpoint security edge. So you don't need to bring an additional product from MuleSoft, or may not leverage all that features from MuleSoft when it comes to security. So I mean, mostly the edge security. I mean, you can still have an API gateway. You can still have all those features around the API gateway where you throttle, do the DDoS attack, whitelisting, and all that. But again, you are a small portion when it comes to at an infrastructure level. There are many things is already handled by the public clouds. Be it edge security with your web application firewalls. All that stuff is already handled by the cluster. So you don't want to kind of duplicate that effort. So you have to be cognizant enough to what feature you want to let go and what feature you want to implement within the Mule. So you need to have that discussion with the security folks. And the log forwarding, right? So, again, you're riding on a public cluster, public cloud cluster, right? So many things are out of the box. For example, when you talk about Azure, you have log analytics, you have log forwarding mechanisms. All you have to do is just wire into that feature. So because your MuleSoft, it runs on a pod, right? And the pod has a MuleSoft can simply write to the std out of those console. I mean, in the console, right? And you have ways you can funnel that into that log analytics workspace. And that's part of Azure. So similarly, you have CloudWatch. You have other things, the monitoring, logging. These are already out of the box from this cloud provider. But again, if you have a Titanium edition, right? So and then you already leveraging endpoint monitoring, you are leveraging the visualizers, right? So in that case, it makes more sense to use what you're already using it. So in that case, just leverage endpoint monitoring and the forward logs from these Kubernetes pods to that endpoint monitoring, so that you have one place to view that all the logs. So this is how it looks from an architecture standpoint. So if you look at here, this is like a typical, if I draw any Kubernetes cluster diagram, it will be the same. I remove the MuleSoft and everything the same, right? In a Kubernetes environment, you have nodes that are connected to a network. and each node has pods. And that pods is what I'm depicting here is the MuleSoft applications and run the runtime engine, right? So these are all packaged inside of that pod. So one pod runs, it's kind of co-locating your application and the engine wrapped inside one pod, right? And then you have multiple pods for different applications. But one key differentiating factor is this one long horizontal line, which is the runtime fabric services. So that's something which is running across all the nodes, and we'll see what are those services. That includes an agent, includes some other resource for cluster IP, caching, and all that stuff, which is part of that runtime fabric services. And one more thing, you see these dotted lines up there, and so you see something managed by MuleSoft, which is pretty much, when I say MuleSoft, is the MuleSoft team, and one which is managed by your Ki8 specialist, which is your cloud admin, who is responsible for managing that Kubernetes cluster. Any questions so far? And Ram, I'm not able to see that chat window, so you can just interrupt me and let me know if anyone has any questions.
Yeah, I don't see any questions so far.
Okay, that's good.
Yeah, I'll let you know if any questions are here.
Okay, sounds good. So this slide is pretty much extending the previous slide, which is kind of what are the components, right? So this slide, we're just showing a dotted line between what is MuleSoft team has to do, what is the Kubernetes specialist has to do, and this kind of make a deep dive into that at the component level. So if you see on the blue stuff, which is Mule stuff, and you see that there is the deployment resources, you have replica set, pods, all that. Then the Mule runtime, you have the runtime fabric components, which we'll see shortly. And then what has to be managed by the cloud admin, right? The customer managed one. So that's something, ingress controller, logs and metrics, definitely the host operating system, some cluster resource interfaces, cluster network interfaces, node pools, disk and network. And again, the Kubernetes in general, management of the Kubernetes itself. So one thing I would like to highlight here is that ingress controller. So today we'll be doing pretty much everything here, what is shown in this diagram, right? So I'll show you doing a kind of creating a Kubernetes cluster, creating an ingress controller, and then deploying an applications. So from this, I think pretty much everything you are familiar might be the one which may sound new is this ingress controller, right? So this ingress controller is a lightweight, kind of a gateway, which because it's a cluster, right? So cluster has so many things running inside of it. So how do you make sure that traffic which comes in is going to the right application? So that's where you need a gateway, right? That gateway job is to route the traffic, put some basic security on for the incoming traffic, right? That's all pretty much. So and you may find a little bit of overlapping feature compared to Mule API gateway, right? Even that does also a traffic routing, security, and all that in a more comprehensive way. But this is at a cluster level where you do that traffic routing and security there, and we'll see that today. Okay, so we at 12:21, and for the next 30 minutes or so, this is what I'm going to plan. Create an AKS cluster. I've already done that because it takes 15 minutes to launch it. Create it, so I've already done that. We'll directly go into installing runtime fabric on an AKS cluster, and then we'll configure an ingress controller, and we'll deploy a Mule application. So that may be we'll see how it goes. If time permits, we'll extend that further to securing the traffic from the client. So pretty much playing with the ingress controller and kind of making the whole traffic secure. So that's number 5 and 6. And uninstall cleanup, if time permits, I'll show you, or just a small step to do. Okay, so what are the things you need when you get a runtime fabric, and for the whole overall demo here? So you need Anypoint platform. You can sign for a free trial account, but someone told me in our last meetup that you cannot get a runtime fabric in a free trial account. So I may take that back. Because I'm using my XTV account, so we have that. So second tool is the Azure CLI. That's your command line tool for anything Azure. kubectl, that's your command line tool for Kubernetes. And you can just Google these tools, and even links are here. But again, it's and then Runtime Fabric, RTF CTL, that's again a command line tool for managing Runtime Fabric. That's all pretty much curl. You don't need. You can use Postman or any of the browser, also good. So here is what we are going to focus on. So you see on the screen here, and you see that towards the right-hand side, you have this AKS cluster, right? So that's the Azure Kubernetes Service. So that's the outer, that's the second dotted line in the screen. The first one is the virtual network, because everything resides in a virtual network in Azure, and then we're going to have that Kubernetes cluster inside of that VNet, and we'll be deploying a Mule pod application. You see that pods with M logo, that's a Mule application or Mule pod basically, which is packaging the runtime, the application. So the application today we'll be focusing here is a Hello World application. Our focus is to show you how things work in a runtime fabric environment, not much into how an application works inside of which you already know, right? I mean, if you lift any application, any jar file, just dump it here, and it's the same thing. I mean, because your application doesn't change it, and there is no change to your application. It's just the deployment platform which is changing here, and that's what we'll be focusing on. That's why I kept pretty lightweight Hello World applications for the demo. And the big piece you see here is the N, which is the ingress controller from Nginx. Actually, that's a Kubernetes community-supported version of Nginx. You have many choices when it comes to an ingress controller. You can, go with an HA proxy. You can go from Nginx, but I have selected an open source community edition of Nginx ingress controller. We're not going to focus on the Azure load balancer here. That is default in any Azure environment. And the client apps is pretty much my laptop with a command line being launched. Okay, so let's get started. So our first thing is, I'll get my terminal up. Okay, so they said I'll show you. Okay, so here is the AKS cluster. There we go. Yeah. So if you see here, so you just go to Azure, and there are many ways you can create a cluster, right? So you can just simply type a AZCLI command. That command is you can create a cluster using AZCLI, or you can just go here manually and then create it. So it's up to you. So if you see here, Azure services, create a resource, and then just type, is the Kubernetes service, right? So click create, and then you fill up all this information here. Select and then first thing is you need to create anything with Azure. You guys know already, first thing is a resource group, right? So that's your home for everything, anything, and the further services you want to take from Azure needs a home, which is your resource group. So I've already a MuleSoft RTF demo created a separate resource group, and cluster name, you can just type anything, and I've already created, so I'm just showing over how to do it. But one thing I would like to focus here is a Kubernetes version. So you see there are a bunch of versions from 1.21.7 all the way till 1.23.5. This page keeps refreshing, right? I mean, it keeps changing, right? As in when the new versions are being launched. Whereas, the runtime fabric, what we are going to do today, has a limited choice of version set, because that's something which the Mule has tested and they know for sure this is going to work. So not everything will be compatible with the MuleSoft latest version of RTF. You need to check that compatibility metrics or when you get a new version of Runtime Fabric, see what is the, look at the release notes and see what is the supported version of Kubernetes. So you need to pay attention which one to select from this list. And then node size, I'm just going to default to DS2 V2. That's a prepackaged configuration for anything to do with that tells you how many, what's the CPU, what's the memory, and all that stuff. So you can find more detail up here. So DS2 V2 is a D series DS2 V2 with 2 vCPU, and we're taking 7 gig of RAM, 8 data disk, and yeah, it's enough for our demo. We're just doing a hello world demo. We don't need so much fancy stuff here. Okay, so well, the cluster is already created. I'll show you the name I've given here is AKS MuleSoft RTF, and this is running off of 2 nodes. So if you see here, and this is, I'm using 1.21.7 as my Kubernetes version, and if you see the node pool, I have, this node pool has 2 nodes. You see here, node count 2 nodes. So that's pretty much it. And what else I would like to show you from here. So Kubernetes 1.21.7. Yeah, I think a cluster is good. So it's a clean slate right now. And let's put the runtime fabric in this cluster. So for that, you head to the runtime manager, and I have logged into the runtime, I mean, any point account from Xtivia, and you see here an open runtime manager up from this list, and click on runtime fabric. So if you see here, so you can create. So let's hit create runtime fabric, and what you see, there are 4 options here down below here, right? So the top 3 are the public cloud. Top 3 are the self-managed Kubernetes, right? So you can choose AKS, AWS, Azure, and or Google, right? 3 choices you have. And the last one is what we have done in the previous meetup, which is doing this on an appliance. The VM bare metal, I'm also using that, calling that as an appliance. It's the same thing. So which is bundled with the Kubernetes and Docker. So in this case, we are going to leverage our own. We just created a AKS cluster, right? I was showing you. So we'll be putting our runtime fabric on that cluster. So let me select a name, and I'll just use this Azure Kubernetes services. And this is talking about who is responsible for what, because you are. So read this and accept, and I already talked about it. What does the cloud admin do? What does a MuleSoft admin do? So that's just repeating the same stuff here. So click accept, and oops, it's existing. Okay, where is it? Okay, so it's there. I should have deleted this stuff. It's there from a previous one. Okay, now it's good. So the moment you create this, I think this is similar to what you have done. You get for even, I mean, same thing like you do in appliance. You get create this, it will show ready for activation. Then you get an activation code. So copy that. Activation code, and so what we need to do is open up our command prompt, and basically we do the validation. So we want to make sure that your cluster has all the right resources, right version of Kubernetes, so that we can install this runtime fabric in that AKS cluster. So I'm hitting this. That's the activation code. I just pasted here. You get all tick mark here. you say here is basically checking the cluster resources. And you see a bunch of tick mark here, which is pointing to Amazon AWS, and that's something because your mule's control plane, right? This page right here, what you see, this cloud on this page, right? This is running on AWS, right? This is your control plane. So you need to have a connectivity between Azure to AWS, and that something is internally handled. Yeah, so it's all good. So now let's go ahead and install the runtime fabric. Yes, it's installed, and you'll really appreciate how quick it is. It's not like really just I just typed validate and then RTF curl install, and it's done pretty much. Let me show you. I'll show you here. It says ready for activation. You will see that because you'll see that status being changed, because what is happening is like you are acting on the AKS cluster, right? And then that needs to communicate with this control plane, which is running on Amazon, right? So that's happening right now, and that's why you see. Well, it says ready. It will take a while to update. Registered. See, it says register. It's still communicating in the back. The status will change to
Apply the licensing or?
no, it just that's nothing. It just takes its own time. And one more thing you'll notice here is like the RTF version is 1.12. And there is no that's the latest. Yep, now it's active. You saw that changed. There was a view small. There's a message here saying upgrade to 1.5 or 15 to view the cluster health details. Anyway, so yeah, now it looks okay. Now you see this active, all system operational. It's just a a minute or so to kind of do that chit chat between those two networks from AWS to Azure, and things are ready now. So our cluster is ready, right? See, this is just a minute or so. You're done with the installation, right? So that's pretty cool. And so now what? I mean, we have this cluster ready. We have the RTF ready, right? So the next thing is applying a license, right? So for that, and let's see the status of this RTF kernel status. So this is showing you the status of the cluster, runtime fabric cluster. And I will pause at 1250, and we'll see how far we go from there. So that 10 minutes we'll reserve for the quiz. Okay, so here you see a few things to note here. So remember I was talking about that shared line, which is this runtime fabric services, and which is pretty much the components, agent, these three pretty much, which is running across agent, the cluster IP, and the resource cache. And you see these two node pools, right? I mean, two nodes pretty much. One is this 08, second one is 09. And all this connectivity is to the control plane are running on AWS, and that's also pretty good. So next thing is applying the license. For that, I need to stop sharing my screen because that's a bit confidential, and apply that license quickly. So the command for applying license, I mean, you need to request your team. Oops. Okay. I mean, you need to get that license.lic file, and you can't just simply say, RTF Cuttle and apply license. You basically have to base64 encode that. So the command for that is, base64 hyphen W0 or something, then the license.lic file. To do that, it'll give you a base64 encoded license, and that's what you apply. So I'm typing a command now, RTF Cuttle apply, and then mule hyphen license. I know you cannot see it. And then your license, which I'm going to get that. Here's my license. Yep, this is the license. It's like 984 words or letters. Okay, license is updated. Close this window and start sharing. Okay, and sharing back. Okay, so you can see my screen, right?
Yes.
Okay, so I applied the RTF license. I'm sorry, I'm the mule license basically, and it's irrespective of your RTF or anything. It's just a general mule license. And now, if you go back to runtime manager, right? So you will see all system healthy, and you can associate this with any of the environment, right? So we just install. I'm going to associate this with a dev environment and apply allocation. And you can also add to any of the business groups, or you can share the same across multiple environments. Not a best practice, but yeah, you can. Well, now remember, we are launching inside of, so this is what we're doing here, right? So this. So you created a cluster, you have runtime fabric running inside of it, right? So now you need to do the endpoints, like, or else how will a request which comes from outside of Azure will be able to redirect to the right application, because these are all hiding behind this or hiding inside this cluster, right? These pods. So there is a way you need to configure that inbound traffic, which is the role of this ingress controller, right? As I mentioned before. So this inbound traffic, it's saying that you need to work with your IT team to resolve this issue. Basically, it's saying go ahead and configure an ingress. It's saying because ingress has not been configured. And there are a few advantages of using a custom ingress template. So one thing is you can, as I mentioned before, you can do a traffic routing, like a path mapping, API, and then you can do a security. You can apply some SSLs, certificates and all that. You can pretty much rewrite the APIs. I mean, the path. Let's say you getting an API with a /API and some name here, and then after that you can rewrite that to /API/ something else. So you can always do that rewrite. And then it has a log forwarding. This is what I was telling about. I don't have a titanium subscription. If you do, then this will be, you can tick mark and this whole log will go to endpoint monitoring. You can visualize that. Okay, so let's start with configuring our ingress, because that's the first point, right? You see, once we do that, this whole thing will go away. Okay, so for that, we need to get an ingress template. and I have already. So you need to download that, right? This ingress template. For that, I have already. So we are getting this. This is a command which we'll be using. So I'm getting that ingress controller from the Kubernetes community. I'm getting it from GitHub Kubernetes, and that's ingress nginx. And this is the YAML file. And you know already in Kubernetes world, everything is about YAML. You just get a YAML, apply it, you're done, right? That's what we will do. We are getting our ingress templates ready. So what we just did, we deployed. We haven't even configured it. So that's the second step. We installed it. We now need to configure it. So to configuring it, we open up another template. So you see here, this is the ingress template. And you just apply this template and it's configured. But before we do that, let's understand what are the key components inside of this. So you see here, API version networking.k8 IO, and then kind is ingress. We are putting a ingress resource template. So that's why the kind is ingress. And there are a bunch of annotations here. And these are some specific annotations for nginx, which is rewrite. This is where you rewrite the app, basically. I mean, whatever you get in, you can rewrite, and then this is a regex for rewriting that URL. And the name I'm giving here is RTF ingress template. And one more critical stuff here is the namespace. So, namespace is your like a logical separation of all, right? And and based on this namespace, and this namespace has to be RTF. Why that? The reason behind that is like we have, I have shown you the agent, right, which is that cross-cutting horizontal, is services, which is kind of plays a key role communicating all the nodes. So this is an agent-based architecture where this RTF agent runs in all these nodes, and the way they communicate with this ingress, and remember, this ingress template or ingress resource is not part of MuleSoft. It's outside of MuleSoft, right? So how do they communicate each other? So the moment you put this ingress template inside of this RTF namespace, the agent automatically recognizes that and then starts to communicate with each other. So this is a very key role. If you put something else, this is not going to work. Your inbound won't be able to configure your inbound. So this is critical. Namespace has to be RTF. And this is the remaining stuff are RTF, the class names, rules. This is my host name. I'm giving here rtf.example.com. You can put anything, and then have your IT network team kind of manages that with the DNS to have a meaningful name and then expose outside. And path, that's your path for your application. So let's apply this. So the command for that is to kubectl apply -f and apply this, right? So okay, that's applied. So now let's go back to the runtime fabric. Now see what changed. I didn't refresh anything here. So the inbound traffic automatically, that the warning is gone, and I see a nice base endpoint here, which is the base, right? If you're developing an API which has, let's say, 6 or 7 APIs, one API has 6 or 7 endpoints. So this is what you have, one base endpoints, right? And then you do add further things to that, suffix those details to this URL, right? So the base is here is http://rtf.example.com, and then we'll add more endpoints. So one more thing is like having a custom ingress template is like you can have many endpoints for this given instance of RTF. You can add more and more endpoints to a single instance of RTF. And what you see here is an RTF instance level, right? But I haven't even gone to applications. So with a custom ingress template, you can pretty much add additional path to a given application. So it's a multiple path or multiple endpoints per application, multiple endpoints per RTF instance. So that's why we chose this custom ingress template. So I'll just, I think we have 3 minutes. I'll just quickly deploy an application and we'll pause it there. Um, so the second thing is, let me pause, mute someone. Can you, Ram, can you pause whoever is hearing some background noises? Anyway, so we configured this endpoint, right? So now we'll deploy an application. So before we deploy, well, let's go ahead and deploy. So to click deploy applications, and then I will just say, hello world. Hello world. What's the date today? 05/19/2022. And deployment target. So you see two options here. I'm going to select my runtime fabric and get the file. Because our focus is not much into application, I'm just getting a sample one from Exchange. Just click on example and get a hello world. Okay. So, and one more thing you'll see, I mean, you'll appreciate this. It doesn't matter you select a Cloud Hub or an RTF here, you get the same feature on the bottom. A little bit different. I don't have time to explain the difference, but again, it's the same thing pretty much. We're selecting two replicas, and you're doing a rolling update. I'm leaving all this CPU memory as the minimum because I'm just doing a hello world. I don't need more. So with that, and then so that's a deployment configuration. And then ingress side, I'm just putting an app name. I'm just having one endpoint. You can add many endpoints as you need. I'm just doing a default app name. App name is basically it's going to replace that hello world 05/19/2022. It's already done that for us. So you see here, this is what it looks like, and these are the variables here. Nothing on the property side. You just deploy. So while the deployment is going on, see, we need to let the deployment go on. So now we need to remember this is if you remember that I have given a IP address or like a name which is called rtf.example.com. That's not even doesn't even exist, right? It's not a public URL. I just made it up. So so we need to get a because I'm accessing from my laptop, which is over public IP. So I need to get a public IP of the whole cluster. So that's why we have ingress. It'll give you a public IP address of that Kubernetes cluster or the ingress resource. So to get that public IP, the command is kubectl, get services -n and ingress nginx. Yeah, so this will give me a IP address, external IP address, right? You see it here. So this is the external IP address, and you copy that, and let me go to my demo cheat sheet. I think it hasn't changed since in a while. Yeah, it hasn't changed, and so I'm going to call this. Today is 19. So I'm going to use this RTF, the curl command. My So let me see before I do that. I'm rushing a bit, or else I could have shown a little bit more, but that's okay. I mean, yeah, so you see this is running. You have two replicas, 2x2 started. And if you do I'll just show one get parts. Seeing the Kubernetes get parts, and there is a command. I think that's
-f.
Yeah. I'm getting it from all. I'm going to do a wide. I think that will be nice. Oh, wide. Oops, that's not O. Oh, wide. Then I'm trying to do with all namespaces. All name. Okay. So I'm trying to show you here. You can see all the namespace we have. I have to zoom out. But if you see the namespace, this column right here, the first column. Let me just focus on that first. Okay. I know it's a bit smaller. See, this is the application. Hello world, and it's running on a different namespace. See, it's in a different namespace. Then we have Ingress Nginx on its own namespace, and then we have all this clustered. This cube system is the cluster, right? That's running on its own, and the agent, the runtime fabric, the runtime is right here. It's all within RTF namespace. So and our application is running 2x2 running. This is all good. Okay. So now let's just do and hit that curl command. So what this will do, what this command is doing basically, I mean, you have a better way of doing this. You know, you don't need to resolve an rtfexample.com. Let's say you are a let's say you are a Geico or something, right? I mean, you just do rtf.geico.com. Public IP already mapped. I'm using a curl command to resolve this rtf.example.com to this IP address, which is external IP. Yep, I got a response back, hello world. So that's working. So that's the basic hello world example here. And 6 minutes left. Over to Ram. I mean, I can go on, or you want to take up the quiz? It's up to you.
Yeah. Thanks. Thanks, Mani. I think I'll go ahead and open the quiz. Unless if someone is having any questions, you can ask. We'll wait for a couple of minutes from
I mean,
our
I
end.
will maybe I'll quickly spend 1 more minute and show the remaining. I won't do the demo as such, but I'll just show what exactly is going to happen, if that's okay.
Yeah, go ahead.
Okay. So what you noticed here is I'm calling this example, this hello world over a AT port. I'm not securing anything. It's just a basic HTTP API, right? But well, we need to, if we have to secure that traffic, if you see this diagram, you see these locks, right? So we are trying to secure the traffic between client apps and the ingress controller, and from ingress controller to the pod. So we want to make a complete end-to-end security or the last mile security. And all that configuration has to be done mostly in the ingress controller and few in that mule application. So for that, the key part here is to inside this ingress template. Where did it go? Yeah, I see this ingress template I was showing you before, and so if you just have to secure the traffic from the front end to this ingress, like this part, this first lock, right here, and all you need to do is like go open this ingress template, same ingress template, and then just put a TLS section here. And I'm saying TLS on rtfexample.com. I have a secret name, and we apply this. So this is a secret name. You need to create a key, create a certificate, and then create a secret out of that. So, and then that's a Kubernetes secret. So you apply these three, and then you'll be all secure. So your front end is secure. So to make your backend secure, which is this piece from the ingress controller all the way to the pod, you need to do a security on both sides. You need to make your application, which is this MuleSoft application, secure. Make an HTTPS. So you know how to do that. You put a key store and then put a TLS. You do that change on this application side, and you make a change on this same ingress template, and you tell the ingress template to connect with an application which is so-called backend with an HTTPS protocol. So for that, this is how it looks like. Now, one line, nothing else. Just one line annotation I'm putting here. Backend protocol is HTTPS, nothing else. So just, I mean, I truly appreciate the way things have been simplified. At this end of the session, I would like you guys to think like it's not. I mean, installation didn't took much, maybe like a few minutes. Well, you have to have your cluster ready, maybe 15, 20 minutes, but max 1 or 2 hour job to be in a proper environment. Doesn't take more for me if I do it maybe like 15, 20 minutes all which in front of you. But again, you have process and standards, so it takes a little more time. And then making these changes, making security, traffic routing, all these are a piece of cake, right? It's just you put one line here, and this makes your backend traffic secure. And on the other side, you just make your application, the mule application, right? You just do make it, put a TLS context here, put some key store, and you're done. And then you test with the curve and test it from the front end with HTTPS. It should work. And that's the demo. I could not show you that. But over to you, Ram. That's all I wanted to talk about. And uninstallation is even easier. Just say RTF throttle, uninstall, and just do. You don't do that often. And I just want to show you. Oh, bad window. Yeah, Ram, while I was doing it, you can get started. I mean, this command will just remove everything. Let me stop sharing. You want to share something?
Yeah, I think we need to open a quiz from another website.
Okay, I stopped sharing.
Yeah. Okay. We're almost end of the session now, so I am opening a quiz. We have 5 questions. Those who answer first, we'll get vouchers for the training and certifications. I think it's a certification voucher. Okay. So be prepared for that. Let me share my screen here. Second. So please, everyone, you can join menti.com using this code 766-89174, so that we can start the quiz. Meanwhile, Money, I see 1 or 2 questions in the chat. If you want, you can respond there.
Yeah, sure. I'll take care of that. I think you already answered, Naresh, pretty much all of them.
Yeah. Uh, yeah. Maybe few at the end, I guess.
Ramesh, Arun. Yeah, I'll reply to him.
Okay, I'm starting. It's almost 16 people. I see many 35 audience. So I see only 16 joined. Wait for 1 more minute. 17. Okay, let me start. So you have 5 questions. You have 20 seconds to answer each question. So you can answer from your mobile or tablet or wherever you log in. First question.
Yeah.
Okay. Let's go back to the second question. Oh, nice. Madhav, Jinu, and Krishna leading. It's tricky. Oh, nice. Okay. Next, fourth question.
I haven't covered this today, by the way. So
Oh,
you can
yeah.
ignore this. I didn't get time to cover.
Yeah, let's see if someone knows about it. Oh, good. Very few people. Madhav. Okay. So I'm stopping sharing. I need emails from uh, the winners. I'll quickly tell the winners. Madhav, Gina, and Krishna. Rajalakshmi. Madhav, Gina, and Rajalakshmi. Can you please give your email so that we can request certification vouchers? Madhav, Rajalakshmi, and Gino. Madhav, Gino, and Rajalakshmi. No, it's a third place only, I guess. I just checked it. It's showing on your screen. Can you please send your emails in the chat box? We'll be closing this session in a few minutes. Okay. Yeah, thank you. I think it's nice session.